Of course, there's also the space station history, the Mir, the Saudi program that we're all kind of familiar with. In some sense, when I think about what's interesting about space, what really captures my imagination, it's a couple of things really. First of all, like I said, the value of looking back at the Earth from space that the astronauts had, that kind of perspective, when we realize that we all just live on this tiny little planet, is amazing. Somebody sent me this picture last week. This is a picture of the Earth. If you were to take all the water in the oceans, in fresh water and everything, and put it in one ball, that's how big the ball would be. If you took all the atmosphere at 1 atmospheric pressure and put it next to the Earth, that's how big it would be. This really gives you some sense for kind of how Earth really is this very fragile, thin ecosystem. This little thin layer on top of the planet. And, that's something that we've really gotten in space, and that perspective looking down on Earth has been incredible. But there's another perspective that I think is equally valuable, and that's the opposite one. That's, sitting on Earth, looking up at space. Pretty much everybody's had the experience at some time or another, looking up at the stars and wondering, is there somebody looking back at us? Even a 5-year-old can kind of appreciate how kind of profound that question is. Now, the whole UFO thing, there were kind of reports back in, history of demons and flying chariots, and then in World War II, the Foo Fighters. But really, it was after World War II that it really got going in full swing. I think a lot of that was in response to, for the first time, we had the power to destroy ourselves. And that scared us, And in some sense, we were also getting a sense of the fact that we could actually travel to the stars one day and go into space. And so we started looking up and imagining, okay, if somebody's up there, what are they going to be like? What part of humanity are they going to reflect? Are they going to be conquerors? Maybe there'll be adult supervision. They'll show up and help us protect ourselves. It's almost like we're little kids with matches, and we're 3 years old, and we're running, we're thinking, oh, I shouldn't have matches. Maybe an adult will come save me. Maybe there'll be pranksters showing up, doing funny things to our planet. Maybe they just want to come by and say hi. In some sense, when we imagine aliens, we tend to ascribe a full range of human traits and abilities to them. All the way from very malevolent to, very benevolent, very kind of saintly almost. In some sense, it's kind of an extension of the Copernican principle. If humans are not the center of the universe, then maybe we just represent some localized subset of intelligent sentience. And what things about us are uniquely human? And what things are we likely to share with other intelligence that we might meet or hear from one day out in space? And so, humans really, in some sense, or aliens in some sense, really represent aspects of humanity, which is also why I find robots fascinating, because I think they both are lenses on the same thing. When you look at robots, especially the ones trying to mimic human form, if you look at a robot hand, and you try to actually design the same capabilities that a human hand has, you realize what a wonderful thing this is, and how hard it is to replicate. Very much in the same way that when people were watching 2001, they take for granted that this computer can have natural, smooth conversations and common sense reasoning. But when we try to reconstruct it, we find out, in fact, no, that's not easy. That's the really unique thing about being human. Playing chess is the easy part. So in some sense, aliens and robots both, to me, become lenses and magnifiers on what it means to be human. And the SETI program, which is the Search for Extraterrestrial Intelligence, is a really interesting kind of spin on that. This really started back with Frank Drake coming up with this idea of Drake's equation. He actually just works down the street, might even be here tonight for all I know. But basically, he was the first person to kind of look and say, how many intelligences are likely to be out there? And Drake's equation is simply looking at how many stars are out there in our galaxy, times how many planets, times how many of those have life, times how many have intelligence, et cetera, et cetera. What's interesting about this equation, and what also later became astrobiology, or the study of life as it might exist, not just here on Earth, is that it's looking at things on a very large galactic scale, as well as a very, very small microbial scale. It's covering almost every subject in science, from physics to chemistry to astronomy to things like civics, economics, sociology. Way up at the high level, looking at galaxies, we see the galaxies, in fact, especially spiral galaxies, are very intricate things. They have these arms, these dust lanes. In fact, about half of what's in a galaxy is in dust, and about half is in stars. There's a very interesting kind of process that stars go through. Their evolution, they eventually kind of return a lot of that gas back into the system, especially the large ones, which go out as supernova. Basically, you have these beautiful nebulae, which are dust clouds, that collapse into stars. Stars form. Eventually, they die. A lot of them blow up supernova. They return dust back. And so there's this kind of circular dust to stars back to dust. You may have heard the term that we're all made of stardust. And this is basically how we know that. Because all the heavier elements, above about hydrogen and helium, were formed inside of a star in nuclear fusion. So almost all the elements in your body, except for hydrogen, were almost certainly formed inside of another star that eventually had to blow up, return the dust into space from which the Earth formed, and that's what your body was built out of. Now, looking at this kind of system, these spiral arms and all that, there's some interesting dynamics. First of all, these arms, they don't dissolve. They actually keep their structure as they rotate. They rotate around the galaxy, in our galaxy, about once every 200 million years. Now, if you look at stars, though, stars are actually gravitational. So stars closer to the center rotate faster than stars further out, which means that most stars are actually passing through these spiral arms repeatedly, very often. These spiral arms are very dangerous areas of high radiation because that's where a lot of supernovas are happening. So if we were passing through these arms frequently like that, it'd be a very dangerous thing. But there's one distance that these stars are orbiting almost exactly the same speed as the arms, which means that they're very, very seldomly going through these arms. And as it actually turns out, we're in the middle of that band. So it might in fact be a galactic habitable zone. So this is up at the very large scale as we're looking out wondering, where might aliens be? What might be the things that kind of cause them? Maybe Earth isn't so common after all. Maybe there are some aspects of Earth that are in fact fairly rare. We know that we have Jupiter, which is this gigantic gravitational shield. Jupiter in fact weighs quite a bit more, about twice as much as all the other planets put together, which means that when junk comes into our planetary system, most of it ends up hitting Jupiter. So Jupiter is this giant shield that shielded Earth from huge amounts of bombardment. The moon as well, which is now about a quarter million miles away from Earth. When we first captured the moon, it used to be very, very close, 14,000 miles away. If you can imagine how large that would be in the sky. And it was so close to the Earth when we first captured it that it was causing 1 kilometer land tides twice a day. You can imagine that. Twice a day, the ground itself would be going up and down by 1 kilometer, and that was the tidal effect of the moon when we first captured it. Ever since then, it's been slowly spiraling out at the rate of about 1 inch per year. But because of that, it's locked Earth into a very rigid kind of axial configuration that most planets don't have. Now, looking down at the very small, the very local, how did life form? Did life form from chemistry becoming more complex, naturally, evolving? Or did it come from outer space? And these are the questions that, to me, just spark my imagination. Now, I have to say, I'm not a space historian, and I'm not a scientist. I just kind of enjoy pretending to be. What I do actually is I spend my time designing video games. And so the game I'm working on now really is based upon a lot of these passions, trying to convey the same excitement for these things to other people. One thing about astronomy that's always kind of bugged me is that usually you go into like a planetarium or you look at a star map and you get the sense that astronomy is so flat. Here's the flat map of stars. But really, once you get to space, it's an incredibly 3D thing. And it's like the stellar zoo of all these kind of wonderful objects that you find. And I wanted to give players the sense of kind of traveling around there, getting a sense of exploring the toy galaxy, and playing out some of their favorite kind of plots or archetypes from their favorite fiction. So the game I'm working on now is 4. I was going to give a demo of it, but I would have had to rush this talk too fast. We actually have it in the back there on several workstations, and you can get there and shoot some of the space game because it would have been too washed out on these screens up here. But I encourage you to go check it out. And basically, I want to give people that excitement that I have for astronomy, that I've gotten since I was very young in the 60s, when basically the future was basically unlimited, and I knew that we were going to be living on the moon. I know we're not going to be living on the moon right now. In 2001, we weren't, and we probably won't be for 30 years, at least I won't be. But yet, I think the direction the future has taken is every bit as intriguing and inspiring as it was when I was a kid. So, thank you very much.